Let's look at number 5. Oops. Oops. There we go. So factor it. We have quadratics in the numerator and denominator. I think we're just going to do quadratics. So we have cubics, but that's an easy one. So yeah, if it is a cubic, it'll be a very easy one like that with a GCF. If it's quadratic, though, you'll make sure to be able to factor it. So again, any way you want to factor it, factor it. 2x something, x something. Both of these somethings have to be 1. I need this to be negative, so that means that's a negative and that's a positive. If you want to do that method for factoring, just looking at it and doing it, that's perfectly fine. If you want to plug it into your calculator or a Desmos, get what the zeros are and use the opposite. Let me do that because it has a fraction. So yes, that will be the factor, but let me do it this way so you can see what you do when you have a fraction. 2x squared minus x minus 1. Now look here, 0.5. Hopefully you know that's a half. So negative a half. And x also equals 1. This one's easy. Just make it equal 0 by subtracting 1. That's one factor. For this one, we have to multiply both sides by our denominator first because we don't do fractions. No fractions are allowed. Multiply both sides by 2 first. Let me just get this out of the way. So 2x would equal negative 1. Add 1 to both sides. 2x plus 1 equals 0. So that's my other factor. 2x plus 1 and x minus 1. So that's my factors. I need to see those, people. I mean, there's also Wolfram out there if you really just don't care to do any work. It is a computational engine. Now on the bottom, that's going to be x minus 4, x plus 3. That a term is 1, so it's really easy. I just need to find the factors of negative 12 that combine to give me negative 1. So a negative 4 and a positive 3 will do that. You use that. There. So I'm looking, nothing's canceling here, people. Okay, so that is simplified. You have to make sure you factor it first to make sure nothing cancels though. So that means I've got 2 vertical asymptotes. So let me start with my y-intercept. For my y-intercept, it's actually easier to look at the original function. This is all 0, this is all 0. I have negative 1 over negative 12 is 1/12. Probably not going to pop that because, yeah, it's tiny. But we should know it's at least positive, so we need to make sure it's going to be up here somewhere. If we have it down here somewhere, we know we messed up. What else? X-intercept. That means my numerator is 0. That means I have 2 x-intercepts, which if you did this, it gives them to you, negative a half and 1 already. So x-intercept of negative a half. And I'll put them with comma. 1. Vertical asymptotes. X is 4 and negative 3. So it's wherever the denominator equals 0, it equals 0 at 4, and it equals 0 at -3. Again, if you use a calculator or Desmos to find the factors here, it started by giving you the solutions, so that's what you need for your vertical asymptotes. The numerator solutions give you the x-intercepts. Horizontal asymptotes, same degree, so remember we just divide those leading coefficients. Y equals 2/1, which is 2. Whole, nothing canceled, no whole. Definitely want to look at the graph before I even try to type the domain and range, though. Nah. So I guess I'll start by plotting my x-intercepts. -1/2, so somewhere around there. Good enough. And 1. And then somewhere, let me actually put that. It's going to be above the 0/12 is above the axis. So this is going to look something like this here, it looks like. Maybe a parabola kind of shape there. Plot my asymptote. Let's see, y equals 2. I'm just using red for my asymptotes just to make it consistent. 4 and -3. I'll start with -3. Oh, nice. So that was convenient. It saved my settings. Oh no. There. So this is what we got going on. So we know that this middle piece is going to look something like this, but we have no clue what's going on over here or over here. Again, we could plot some points on either side. So plug in something like 1, 2, 3, 4, 5, and -4, and see what happens. Yes. So I've got this. Let me group it so I can easily just hit this fraction bar afterwards. And x squared minus x minus 12. Oops. Okay, so that's what it looks like. And if we look, we have -5, 0. Oh, another. Oh, that's a 12. Okay, yeah. Oh, and it also gives us our maximum point right here. So it's actually not at our y-intercept. It goes a little bit further and puts our maximum right here. Don't worry about it. Just make a general parabola shape here. It's good to go. Let's get at least one nice point. -5, 3. I'm going to plot that. -5, 3. Let's see. 1, 2, 3, 4, 5. Let me count. Yeah. -5, 3. Okay. So I'm going to use that point. I'm just going to sketch that rest of that. And let's see. This looks like a nice point. 7, 3. Cool. One, 2, 3, 4, 5, 6, 7. Something like that. And we're just going to sketch these things, not even worrying in the slightest how close it is. So I know it's going to look something like this. I have no idea why my graph keeps disappearing sometimes. There we go. Blue, 4 points. Good enough. So I'm going to do something like this. Yeah, about like that works. Terrible, terrible, but good enough. You touch the asymptote. That's horrible. At least that a little bit. Whole loop here shouldn't be going on, but I got this. Hit my setting. Cool. So sometimes it saves your settings, sometimes it doesn't. I have no idea why. Again, it's the first time using this slides this way. So if you know stuff I don't, please let me know. Domain and range. So now we can actually do that. Definitely need Desmos for this. So we need this point right here. So 0.238.092. I'm curious. Let me see what the key actually says for this domain, because we're going to need to go from negative infinity to this point, 0.092. I'll check in a minute. And then from 0.092 up until 2, and then from 2 to infinity. So it's going to be another triple interval here. For the x's, we have one split here, one split here. So they're both going to look something like this. Okay, so for the x's, those are easy enough. There's a split at -3, and there's a split at 4. Did I put -0? I did put -0. Didn't mean to put -0. Okay, from negative infinity, we're going all the way up until this point right here, 0.092. So you have to use Desmos on this one. 0.092 until this 2 right here, my horizontal asymptote, is not there, is it? I don't have anything there, do I? I don't have anything in this range. Test it out. My next jump is from 2 to infinity. That's it. There's nothing here, people. So don't put something there. So that's my domain, my range will look like. This one was pretty tricky with the range. Luckily, Desmos is there for us. Hover over that point, and that gives you your maximum, 0.092. Well, that's a nice fraction or something. 23 over 250, sure, whatever, no idea. Give me just a second. I'm going to pause it and look on the answer key and see what the creator of this actually said was the range and show you. So let me find it first. So here's how they write it. I like interval notation. Set notation is just not used. On my math lab, which your dual enrollment people will be using, this is not going to be accessible. So this is how they wrote it. So I guess they did maybe they used some sort of graphing utility and found out that point right there. Okay, just curious. Last one. I know this is taking forever. My apologies. This one, super easy to factor. GCF is x squared. So I just factor that out. X squared. So to get a superscript, I hit command dot. You need to look in here, format, text, superscript button. It'll tell you the keyboard shortcut. Mine is command dot. Windows would probably control or alt dot, I guess. But you can just go from format, text, superscript. You can just click it if you prefer. X squared, and then x plus 3 is left over. So I factor that out. Just factor out a GCF there. This one's going to be x plus 3, x minus 1. Okay. There we go. Simplify it. It's going to be x squared over x minus 1. Again, command dot for me there. Oops. I think I need to be further outside of this text box to actually have the scribble work. There we go. I think that's the problem. If you have a text box, you actually like click in it before you actually start drawing, so it doesn't draw anything. So that's my simplified function. Definitely going to use decimals for this one, but it's going to look like a volcano, I think. Usually if it's squared or fourth degree up there, that's what they, you're going to do this or you're going to do that kind of thing. I think it's going to look like this. It's been a while since I've done these by hand, but I had to memorize all this stuff. I'm letting you use decimals. If I let x be 0, I get 0. So my x-intercept is also 0, 0. Vertical asymptote. Well, let's go ahead and take care of this right here. We had a hole at -3. Before I forget, because I'm good at that. And if I plug -3 into this thing, I get 9 over 2. If you need to use a calculator, please do, because I just screwed up. Get 9 over. I plugged in -3, not 3. That's going to be -9 over 4. Yeah, use a calculator so you don't screw up like I do. So parentheses, anytime you're squaring something and you're plugging it in, plug it in with parentheses. -3 minus 1. There we go, -9 over 4. Sorry, but vertical asymptote, that's going to be 1, 1. X equals 1. Now notice the degree of the numerator is bigger than the degree of the denominator, so there's no horizontal asymptote. And for this class, that's all you're going to worry about. I'm going to show you your oblique asymptote whenever we're graphing this thing. So to get your oblique asymptote, you do long division with the unsimplified version. What if we work on the simplified version? No, excuse me. Excuse me. Where was I? Okay, so now we're going to graph it. 9/4, that's 2 and a fourth, negative 2 and a fourth, so negative 2.25. Let me plot that first. Negative 3, negative 2, negative 2, and a little bit. It's about right there. And again, that's my hole. I'll make that white. Got a point at 0, 0. Plot that. Vertical asymptote at x equals 1. What am I doing? Sorry. Let's format that. We've got a vertical asymptote there. Now I'm going to go over here and by hand do the division real quick, just so you can see what the slant asymptote is. I don't expect you to do this. Just use Desmos and sketch it like it looks. It's very interesting. X squared plus 2x minus 3 goes into, long division. You should be familiar with this. So I'm not going to bother with scratch work. That's going to be x. It's going to be x cubed plus 2x squared and minus 3x. I don't care about that. Subtract. That's going to be 1 x squared. That's going to be 1 x plus 1. So if I sketch this line, that's going to be another asymptote. I'm going to do that for you. X plus 1 has a y-intercept of 1 and a slope of 1, so it's going to look like this. Let me just say 1, 2, 3. Eight would be 9. Start here as a slope of 1. So this is what my graph should look like. Or my horizontal asymptote, my oblique asymptote. Actually make it 4 so it's thinner. I'm gonna have an oblique asymptote going like that. So my graph can look something like this scissor shape here. It's either gonna be, well, I know it's gonna be in this section. So it's gonna be either in this section or this section. I don't know off the top of my head. I think it's gonna be up here just by looking at it. But let's use decimals. So again, you don't have to do this part. I'm gonna do it just so you can see it. It's x cubed plus 3x squared over x squared plus 2x minus 3. And I'm also going to graph x plus 1. So you can actually see right there, that's my oblique asymptote. My graph just keeps getting closer and closer to those lines. It's never going to cross that oblique asymptote there. Now we also know at -3, there should be a hole. Let's see, -3, undefined. So we have this hole right here. So we make sure we have that hole. We have our asymptotes. And we just kind of follow them. You notice we also have an asymptote here. at x equals 1. And you can see how our graph just fits right in that little scissor slot. Hard to tell. Let me make this. I don't want to not color it. Why does it have a slider? I don't know. Anyway, so you can see that's what it looks like. Sketch it. Good to go. Get some points here. I like these little corner pieces if I can. 2, 4, and 0, 0. So 2, 4, and 0, 0 are my little corners. And then I'm just going to go through and scribble that. So it's going to follow that, and it's going to follow that. And again, if you don't draw your slant asymptote, that's fine. Just kind of sketch it like it looks like on Desmos. And it's going to look something like that. All right, that's my setting space. That's nice. Again, I'm going to make sure that holds on top by cutting and pasting it. So I'm going to go ahead and remove that asymptote since you don't have to graph it. Something like that. That's good enough for me. Let's see, what else? Domain and range. Notice though, our slant asymptote does not affect our domain or our range because it's, it's at a slant. It's not going to prevent us from getting any x or y values. What does prevent us from getting those x and y values is my vertical asymptote here. So we have to find out what these points actually are. And if we do have that, if we do have that asymptote, it kind of helps. 2, 4, and 0, 0. We're going to use those points. We're going to use 0. So it's going from negative infinity to 0, and then from 4, yeah, it's like those points to infinity. So Desmos does give you those minimum points. That's very nice of it. So 2, 4, and 0, 0. That's these points there. That's what's going to affect my range. So my range is going to be something like this. Negative, actually it's going to be, because I'm not going to have anything inside the middle, right? So just like this one, we don't have anything in the middle. Negative infinity to 0, and then from 4 to infinity. My domain is everything except for this right here, which is 1. And that's it. So yeah, I'm not going to give you too terribly many of these people. They do take a little while to do, especially with using slides to do it. But I'm going to probably give you like 5. You can do 5. I think you can do 5. And just, do your best. If you have questions, ask. Put it on the stream. And whenever you're done, submit it so we can take a look at it and help you out if you have some errors. That's it for today.